tunnel snakes.
Our goal: to measure the output of a nuclear reactor by detecting light emission.
Keep the fission process going while keeping it under control. And the moderator can change the rate at which neutrons react. So, the main purpose of the nuclear reactor is to produce energy to create power. Also, a side effect of nuclear reactors is Cherenkov radiation. It occurs when a charged particle passes through a dielectric medium that is greater than the phase velocity of light in that medium. So the blue light is attributed to the deceleration of electrons. Also, it is proportional to the number of fissions. So, the brighter the Cherenkov radiation, the more fissions are occurring in the reactor. Also, in pool-type reactors, beta particles are released as fission products decay. So therefore, the glow continues. Thank you.
Needed a plan. Step 1, we figured out the electronics. After researching photodiodes, resistors, and other detectors, we decided that the photoresistors would be the cheapest and most effective way to detect light. Step 2, we read the project summary. We were required to use PVC piping for the main probe. We decided that a plastic cap would not distort light too much and would provide decent insulation for the probe. Step 3, we built the circuit. We tested the circuit by turning lights on and off to ensure that the photoresistors were working properly. Luckily for us, the circuit performed exactly how we wanted it to. Step 4, we built the waterproof head. Took a lot of glue, but it was waterproof after brief testing. We then attached it to the PVC pipes and stuffed the end with cotton balls. Since our prototype worked, we kept it.
We do in FEDD. We finished in 4th place. Our mystery level guess is 385 kilowatts, when the actual level was 400 kilowatts, giving us a percent error of 3.7%. We attribute our error to the heat given off by the reactor, which would have interfered with our probe's readings.
There are several things that we would do differently if we had the opportunity to redo the project again, and one of the major ones is choosing a different type of sensor. We are recommended either a photodiode or a photoresistor. However, of these two options, one is a much better choice. By choosing a photodiode over a photoresistor, you will be measuring light with an output of current rather than the restriction of current from a photoresistor. To summarize, use a photodiode instead of a photoresistor. One of the other major things that we would like to do would be using a coupling that fits directly in or over the pipe. The way we did allows water to seep in at an additional place over what you would normally experience if you didn't use a rubber coupling like this. Using a coupling as we did also requires such as much sealant and rubber cement. This also greatly increases the possibilities of leaking once your probe is submerged in the pool. The advice that we would give to other groups that work on this project is to start early. We started several weeks in advance and we're still working right up until our test date and even after our test date so that we could have a finished probe to retest. Waterproofing the probe takes quite a bit of time, so make sure you have ample time to waterproof your probe and make sure that it is ready to go for your test date.